Hi everyone, welcome back to my channel FRM Unplugged. So today we will be doing the second part of the common univariate distributions. The last time we solved some numericals on the normal distribution. Today we will be solving some numericals on Poisson and binomial distribution. So from exam perspective, at least from the numericals perspective, it is important we are almost kind of thorough with Poisson, binomial and normal, right? Students T is also important, but not to that extent in terms of numericals. Just for numericals, let's keep our eyes and ears open for normal mainly, and then Poisson and binomial. Okay, so let us dive straight into the numericals. Now let us look at the first question, right? So in Poisson, just keep this in mind, and obviously once you start doing it, it will be ingrained in our mind that we will be requiring the calculator, because the formula for Poisson distribution is like e to the power minus lambda t to the power n divided by factorial n. So that's the plain and simple straight cut formula. We just need to plug in the numbers. For Poisson, either it will be something very straightforward like this, the first question, and there will be one variation also that we will discuss. It is somewhere here around number 6. So this is also a small variant of the first. So let's start with the first. Okay. Now what it is saying. So like we know, the Poisson is basically used for modeling the number of kind of defects or number of customer complaints in a, let's say, 48 hour or a 72 or 96 hour time frame, or maybe 1 month or 2 months like that. So here it is saying that the expected number of defaults each month is 4, which means what? Lambda is equal to 4, and what is the probability that there are exactly 3 defaults? So for exact 3 defaults, how we will do? Okay, so just let us do the first. Let us write the formula so that we are not always. I mean, it takes maybe 30 seconds extra to write the formula, but you will never end up making any mistake because there are so many things to remember. Into e to the power minus lambda t. This is the formula. We will just need to plug in the numbers. Is equal to 4 into 1 to the power 3 e to the power minus 1 divided by factorial 3. This is the answer. 4. So e to the power minus 4, I mean, you can just solve it using your calculator and find out the value. So this is over 1 month. So for 2 months, the same formula we will do. Only thing is we will do in place of 1, we will put 2. So t, the previous scenario was 1. In the next one, which is 2 months, the t will be 2. That's all. The other things remain the same. So this is how we will need to do the Poisson distribution. Okay, let us go to the another version of Poisson distribution, which is here in point 6, the question number 6, right? So here it is, what they are asking is the loss frequency process is modeled using a Poisson distribution. So here, what is the lambda? Sorry. So what is the lambda they have said here? Lambda is equal to 8 errors per week, right? And we are asked 1 error will be produced tomorrow, which means per day. So we have to make it 8 by 5 is equal to 1.6. This is 1.6 defects, errors per day. So, and then we just solve it using the same formula like we did for the first. So this kind, so you just don't miss out the the time period that they are saying. So here where they have given the lambda per week, whereas they have asked it for tomorrow, which is for 1 day. So just be mindful of this. Otherwise, there is no other complication for Poisson distribution that we can imagine. Okay, now let us look at the second question, right? XYZ, okay, XYZ, this is quarter 4 times a year, so 4 quarters. So quarter 1, 2, 3, 4. Based on the historical, will exceed. Its estimate is 30%. So exceeding is 30%. What is the probability that the XYZ corporation will exceed estimates 3 times in a given year? Okay. So so here, like when we did the topic on permutations and combinations, just keep this in mind here, that had this question been like where the order is important, then it would have been different. But here the order is not required, important. It can be any 3 quarter, 1, 2 or 3, or it is not that the first quarter will not be an exceedance, but second quarter will be, nothing like that. It just says out of 4, any 3 quarter can be exceedance. So obviously we will have how much? 4C3 into what is that it will exceed. So exceed 3 times a year means, so 30%, right, to the power 3, and 70%. So if the exceedance is 30%, not exceeding is 70% into 0.7 to the power 1. This is the answer. Because for this, obviously, see again the fundamental principle of counting. So out of 3 instance, I will have this 30% is the probability of success, so to speak, right? Success means the one that we are asked to see. Success, don't take the meaning of success with the theoretical meaning of success. Take it mathematically. Here the success is exceeding the estimates, which is 30%. So obviously 0.3 into 0.3 into 0.3, and it's given that they are independent. So by using the formula of probability, we will have 0.3 into 0.3 into 0.3 into, there is the fourth one need not be an exceedance, which means it will be like less than the estimate. So that is obviously 70%, because the exceeding and not exceeding are complementary. So this is the final answer. So if you calculate it, this will, the calculation you can do it yourself, but this is how the problem will be solved. See, in the interest of time, I will be skipping doing the actual mathematical calculation that you can anyways do it from your own calculator, right? Now, let us go to the third question. So, what it is asking is, as developed in the meantime, assume that the probability of an exceedance, probability of exceeding, okay, is 5%, and means VAR is some measure of risk. We can discuss VAR, we will discuss later. For now, just know it is just a measure of risk, and whatever I am projecting as VAR, so I am projecting and I am expected that the risk will be less than the one that I projected by my VAR model. So ideally, majority of time it should be below. Only in a few tail events kind of a scenarios it will be exceeding. So which is 5%, and the probability of not exceeding is 95%. Okay. Now what is the probability that there are 2 exceedances over 20 days? Again, this is 20C2 into exceeding, right? So see again, just because this is one very common mistake students do. Here our probability of success, that P, NCX, P to the power X, Q to the power N minus X. So here the success is exceeding. Exceeding actually, in the true meaning of the term, it is actually harmful for the organization. So it can't be a success, so to speak. But for the purpose of using the formula, that is the success. So 20C2 into 5% to the power 2 into 95% to the power 80. This is the answer. If you solve it, you will get the final answer. Now let us get into the fourth question. Here it is saying that our bank's 99% daily VAR is 90. This reflects which? So this reflects the CDF, cumulative distribution function. This does not reflect the PDF or PMF, but the cumulative, total. So if we are saying that this is, let's say 99%, right? So what we are saying is this is the tail event, and this, so there is 99% chance that the VAR, which is value at risk, or which is, just take it for the sake of this discussion, that the potential loss the bank is exposed to, 99% of the time it will be within 1 million, and there is a 1% chance it will be more than 1 million, which is that this is the tail risk. So obviously if this is how VAR is depicted, then this is a CDF, right? So the correct answer is CDF. There is a full literature on VAR that will come in part 1 to some extent, and in part 2 to a large extent. So we can discuss VAR there. Now this is the fifth question, right? So a credit portfolio contains some number of independent credits. Okay. Expected. So here mu is equal to 4 and variance is 3.8, right? So we have to probability of x is equal to 4. This is also slightly, I mean, it's not a difficult, just see it like this. NP is equal to 4 and NPQ is equal to 3.8. This we have been given, right? NPQ is the variance and NP is the mean. So if we divide it, then Q is equal to 3.8 by 4 is equal to 0.95. Therefore, P is equal to 0.05. So the probability, what is the nearest of exactly 4 defaults? So what is the default is 0.05. So out of, okay, then when we apply the formula of NCX, we also have to find out the N. So if P is what, 0.05, N is equal to 80, because 80 into 0.05 is 4. So N is equal to 80. Now we just have to put the formula like this, 80C4 into probability of exactly 4 defaults. So here default is the success. Default is, probability of default is P, 0.05 to the power 4 and 0.95, sorry, to the power 76. This is the answer. You do the calculation, this will be the answer. So sixth we already did. This is also a variance of the Poisson distribution that we just discussed in the first question. Okay, now this question is slightly, the 7th and 8th question is slightly conceptual. Just listen carefully here. Okay, now a third to default basket of credit contains 40 credits. This just means, just let's say this is a basket, there are 40, let's say, bonds or companies, take it whatever way you want. There are 40 companies and third to default basket, which means if any 3 defaults, then this entire basket is considered to have defaulted. Okay, and the probability of default PD is 2%. What is the probability that the basket CDS will be triggered? So which means, when will be the basket CDS be triggered? When the number of defaults is 3 or 4 or 5 up to 40. So, say 36 defaults, then also, if 3 defaults, then also this is considered, this CDS basket will be triggered. So obviously what we will do, find out the probability that there is no default. So how we will find out probability of no default? 40C0 0.02 to the power 0 and 0.98 to the power 40. Like this, we have to find out p x is equal to 1, and we will also have to find out probability of x is equal to 2. So just you add x is equal to 0, 1 and 2, and 1 minus this is probability x is equal to 3 plus x is equal to 4, like that, right? Since either it will default or not default, so it's a discrete one, so it will always be 1, 2, 3, 4, 5, 6 up to 40. So so 3 and above is 1 minus probability of x0, probability of x1, probability of x2. Do the math, you will get the answer. Okay, and then the final one. So this is slightly tricky question. Okay, now what are they asking? That they are saying that what is the, if the there is a perfect default correlation, which means, so there are 40, sorry, so there are 40 companies in this basket, right? If they are perfectly correlated, then everybody will not default or everybody will default. So then what is the probability that the third to default basket CDS will be triggered? What is the probability? It is 2%. It will never be 2% into 2% into 2% like that, because if one is defaulting, entire thing gets into default, because this is 100% correlated. The correlation is 1. So if I am even taking one, what is the probability of one company or one whichever bond issuer is there in the basket defaulting? It is 2%. So the probability that the entire basket will be triggered is also 2%, because one, it's like a tinder box. There is a match box. If one match stick is lighting, entire thing is catching fire. Just the same way it is there here, because it's perfectly correlated. So with this, I think we have kind of done all the variations possible for Poisson, binomial, normal distributions. There could be some additional numericals related to students T or maybe uniform distribution, but those would be basically, we would just need to do some plain vanilla plugging the figures, plugging and doing the maths. Otherwise, I think if we are thorough with these 8 types of problems and the last 10 problems that I did for normal, this 20, all the variations of this 8, so whatever will come in the exam will be the variation of this 18-20 type of problems from the 3rd chapter, which is the common univariate. So with this, we kind of complete the 3rd chapter, which is the common univariate distributions, and we have covered normal, Poisson and binomial. And next we will take up the further chapters on hypothesis, regression and others. Thanks for your time and attention.